Thank you very much, and welcome to my presentation. So I would like to give you some information on the Weekend School because that's where I do this presentation and this voluntary work and teaching with the children. But what is the Weekend School and how did it come about? Well, actually, like 20 years ago, there was a interviewer who was interviewing children in Amsterdam in some underprivileged areas about their expectations about future, and that girl turned the roles and said, "Oh, you have studied at university? Yes. Don't you know an engineer? Because I want to become an engineer and I would like to talk to one to know how that is." And then she realized, the interviewer, that these children do not have in their neighborhood, in their family, people who they can take as an example, who they can learn from, what they could even achieve or dream of being. And so she started a weekend school and said to the Amsterdam University, "You have those rooms standing empty there anyway in the weekend. Can't I get a classroom to get volunteers here teaching to those children?" And the reaction was, "Sure, if you can get 20 children voluntarily into school on Sunday, yep, you can have that." And she went to someone to find finance, same reaction, and actually it worked. And there are now 10 children or 10 weekend schools in the whole of the Netherlands. So they really bridge the gap between society and between school and what is needed in society to live. They also don't abandon them at the end. There's an alumni program, and the data show that there is a result of that. That they have a better expectation, get better placed in society. There are a whole lot of classes provided, as you can see here. The red ones are the ones that I also teach, and there are over 1,000 students in 2016, over 3,500 volunteers. So this is really a big thing. It also inspired a number of other weekend schools, and I'm actually in 2 of them. So this is just a bit of the background. And what I did there, what I set up starting last year, was a curriculum in programming. And I did want to teach the children that it's not only about programming, not only about changing pixels on the screen that they are very familiar with, but it's also really about controlling the environment and being able to work with LEDs and buttons and motors and so on. So that's what I wanted to let them do. So we have 3 to 5 weekend school days. Each is 2 times 75 minutes. And then we give 3 days to the second graders, 11 years old, and 2 days to the 12-year-olds. Actually, we compressed it earlier in 3 days, but we're now going to move to 5 days because this was a too heavy program. So the 3 lessons that we have, the first lesson is to give them some experience in programming, the first steps. So that's a programming in Scratch with some labyrinth that you have to move through. The second one, and that's the one I'm going to discuss here, is this game, and I'll show that. It's physical computing control from Scratch. And the third lesson, they can build this board. They're then programmed from the Raspberry Pi, an Arduino with Arduino IDE. They program this thing in C and C++. And they can then download it, and then when they're done, they are allowed to make one of those themselves and then take that home. So that is something that's but all those lessons have experienced great response, great success. So what do I have? What do I have here? You see on top a 9-volt plug. Then we have an Arduino Nano. And why do I use well, I come to that, why I have an Arduino Nano on that, but this is then connected to a Raspberry Pi where Scratch runs, and that controls this board. So we have an Arduino Nano, very handy in that extension board, where you have 3 pins per GPIO, so VCO plus, minus, and the signal pin. So for example, you can connect servos very easily, a joystick to demonstrate analog input, some buttons and LEDs for digital input-output. And then, I want to have something with servos, try to find something useful. I found these tilt and pan platforms, I think, for GoPro cameras, and you can also then put a duck there, and you'll see what the duck does then. And then it's via USB, it's connected to the Raspberry Pi. So the setup that I use is Scratch, on the one hand, in the Raspberry Pi, and then there is scratchClient, a magnificent program that makes the connection between Scratch and external hardware. Both you can use Arduino Uno or Nano, or it can also directly control the GPIO pins on the Raspberry Pi. But I found it more convenient to actually use an external Arduino for reasons that I will explain later in my presentation. So a powered USB hub is not strictly needed, and then this Arduino Nano, where there is a scratchClient sketch running in that communicates to the scratchClient in the Raspberry, and there's a scratchClient config file where you actually say this pin has this function and it's called that. So that children in Scratch can actually use those symbolic names rather than have to say program pin 11 and so on. So I think that's very helpful. You can set those things up. So the game starts by pressing the joystick, then the LED lights at random, and when the LED lights, the first one who presses gets a point. And if the button is not there, then the other one gets a point. So the one who wins, the duck will turn to you and will make a bow, and otherwise it'll shake no. So let me see that we have here oops, that's the one. Yeah, oh, that's actually me presenting the same presentation last time, because we should have stopped it actually. Where can I go back? Should we go back here? Okay. So let's. Can I go full screen? Yes, I can. And then I can also turn the volume up. Okay, so this is the game that they have to program, and of course they get further information on that. Let me turn down the volume here and stop this. Good, and go back here. So then I come back to the reason why I'm using Arduino, Uno, or could also use, I use a Nano, but it could also be Uno. Well, the Arduino Uno and Nano, they provide analog inputs. That's not there on Raspberry Pi. Arduino also provides a more stable pulse width modulation than there is in the Raspberry Pi, because it's hardware based. Arduino can support real-time protocols, for example, for controlling certain devices. Arduino GPIO pins are 5-fault tolerant. And when you make a mistake and you blow up something, if they would do some different wiring, well, an Arduino costs less than €2.5 for a clone, and damaging a Pi will be much more expensive. And when you need more GPIO pins, you can actually add extra Arduinos. The scratchClients support this, and there is an easier setup and tear down in a contemporary classroom situation, because I have to travel with that through the country, so I have crates with monitors and keyboards and so on, and I have to connect and plug and unplug, and have the whole time to, well, do something on the GPIO pins. That is, I found that not so easy. And okay, we can also some functionality to steer the servos, for example, and fold it up into a default position. So scratchClient, things to know. You can download it from the web page over there. You unpack it, then you install the other packages described in the download file. You adapt the config file to say this pin has that function with that name. There's now actually a excellent UI available, so it's very easy to do. Last year it was based on only XML files, but there's now a program that can actually make those XML files, so it works very well. And then you use the Arduino IDE to program the scratchClient into the Arduino, and then, well, it works all fine. I expect that I had a problem with going over USB hub, but if you don't do that, then it's fine. I mean, that only for the programming, but from the Arduino. And then you start up scratchClient with the config file as a parameter, and there you go. And help, well, there's an excellent documentation available for the program. So the cost and effort for the board, I have actually now, I want to have the ability to give this lesson for 60 children, and of course I need then many people helping, but I have 32 set up so that, so you can do it for about 20 euros. Most of the components are ordered from Aliexpress. That is a benefit of very low prices. And it's almost always shipped for free, and counterintuitive, the less you order, the more chance there is that it's shipped for free. So I have had lots of things there. The disadvantage, you can never find any data sheet or specs. The delivery takes between 2 weeks and 2 months, and about 2% of the shipments never arrive, but then you get your money back, so that's also fine. And for power supplies, do not expect more than 50% out of the rated output, because they never live up to that part of the specification. And occasionally, of course, products run quickly out, so you need to make sure, oh, how many do I need? Well, let's make sure that I get. So that was what I did there. So the bill of material, I'm not going to read this out, but you can see in the material that you can download from GitHub. You can have here the whole material, and see here that it's about 23 euros, but then you also order stuff for more boards. So what else can scratchClient do? You can control pins on the Arduino Nano, and you can do digital in and out, analog in, and pulse width modulation. And there's also a new counter function where you can count pulses on the Arduino up to about 80 Hertz, and it sends a continuously increasing counter over, so you don't miss pulses. Otherwise, you can't reach that sort of frequency easily. It is also possible to get the GPIO pins on Raspberry Pi, and there's also a control for Sonic Pi, Minecraft, well, and a whole lot of other things as listed there. It allows the peripherals to be addressed with comprehensible names rather than pin numbers. It runs also on a Windows PC, and if you then connect an Arduino to that, you can actually from a Windows PC control from scratch. You can control and do physical programming. You can monitor the hardware state or the hardware state of the pins from a browser. You can monitor the hardware state from all workplaces from a central PC if you would want to. It allows also to use predefined configurations for experiments. So you make a configuration for this lesson, for that lesson, and you dynamically invoke them. And you can keep apart multiple connected Arduinos and address the right GPIO pin on this Arduino rather than that Arduino by having the proper configuration file. So my conclusion here is scratchClient is really the ideal software to bring physical computing to Scratch. And there are not the limitations that, say, the GPIO server, for example, has, that it only works with certain boards you can't configure, etc. This is really extensively configurable. So, a small announcement, within a few weeks, scratchClient will also support Scratch 2. Scratch 2 runs runs on the web, but there is an interface to be able to also address this. And Scratch 2 also runs then via the Windows PC or Raspberry Pi, so it's not standalone, but that is because of Scratch 2. So if you want to try for yourself how it works, you can attend my beginner's workshop at 2:30 today, or the advanced workshop at 4 o'clock if you're already familiar with scratchClient. Please drop by in the room 8Z203 to register, so that we know how many places we have to set up. Space is limited. The workshop will be in English, but the material, there is German-spoken support present. Gerhard Hepp, who is the author of scratchClient, actually is here and is German, so you can also get that in German. You will learn how to configure scratchClient and, well, do all of this and build up a test board, and you can, I think you can really learn how to get going with that. So more information you can find at different places, but GitHub and search for Pi and more, and you'll find my stuff. In the last, well, okay, even 3 minutes, I wanted to show you something that is not related to Raspberry Pi, but just to working with children on computing. I have had RSI, repetitive strain injury, so I know how painful it is if you sit wrongly and you get health problems. So what we also do want to teach the children that how they have to work with a computer, how they have to sit. So and then these tables compared to the chairs, for these children are way too high, so they sit like this, and that is not a very good health situation. So we teach them the 5 golden rules of what to do and how to sit. And what I made is these tables, or these extensions to tables, that run with some lathe over the table, and where you can then have the keyboard and the mice. So then they can really sit better. Not that they will get RSI from that one class that we give, but I really want to teach them how they have to live or sit in future, and make sure that they stay healthy. And I must say that if you ask them, do you sometimes already have that you have something in your brain? Yeah, they say, oh yeah, that's what we feel. So I think all the need to also teach children on the non-technical part. And that ends up, so I think I'm probably good in time. Good, okay. Good, so, any questions from anyone? Yep.
So I have a question.
Yep.
I've seen Scratch sometimes, and I know that it has a pretty intuitive interface, but I keep wondering if you introduce it to children at the age of 11, how fast are they able to actually do stuff on their own instead of just following the guidelines that you give them?
Well, I think they are pretty fast in being able to do that and understanding. And they sometimes already say, "Oh, we'll just do something else," and they go making something else, and all sort of interesting extensions that they made. So yes, but of course it is not equal for all 11-year-olds. There are some that after the lesson are still like, programming, it's complicated, and there are children that well, already during the class do all sort of stuff in that program that we had never envisioned. And I think it is very intuitive. And what we also do, we give them instruction. Of course, the first thing is like, okay, put this in and then see it working. But the next steps are, okay, you need to make this functionality. You need to use these blocks. So we just disconnect all of the statements, let's say, in Scratch, give that as a picture, and say, well, now figure out how you do that. That's at least, and also works better than what we done in the later lesson. If we have them program in Arduino, yeah, and then of course you have with C, and you have, if you forget a semicolon and so on, and yeah, that is more complicated. But still, they're very enthusiastic in doing that, and it's not only in how much are they then able to reproduce, but also the enthusiasm that they have, and the fact that they can see that this is something that they could dream of becoming and diving more into. That's also a purpose of the Weekend School.
Any more questions?
Anyone else? Yes. Yeah, so what I have also, I was saying I would do mathematics, that is separate. I'm doing physics, and then we have a carousel around certain test setups. One of the setups is electronics, or electro, a switch with, there's a normal switch, parallel, serial, and alternating switch. And at some moment, interestingly, one of the children said, "Oh, that I really would like to make at home. How can I make that?" And I said, "Well, then come see me after class." And normally they have already long forgotten that, but he hadn't, and I didn't want him to put in an exceptional situation. So I said to the teacher, "Say to the class that if they want, it's a lot of work. It has to be done after school time." But then they're also allowed to. And I thought, well, maybe there's one or two others that want to do that. Then I had 20. And that actually, the class was 24 and 20 of them wanted to do that. So then I developed a class, let's say in electro, well, not really electronics, but they can then, with a modern breadboard, get LEDs in and wires and so on. And that has been a hit since then. So I think they really start learning of how a number of these basic things work, and they ask, can they work through the break? Can they stay longer to actually make more? And so that is, and yeah, I mean, how much will they really understand at that age of all this stuff? No, probably not all of that. But I think the enthusiasm of working with electronics with that class is actually there. If you want to know more of that class and see the course material, then you're welcome to approach me, and you can get that. But of course, that's in Dutch then, but I can guide you to what it is. But there are many pictures, because one thing, if you're teaching for children that age, all these letters, all these characters, I mean, reading is not something that they are actually very enthusiastic about, let alone understanding what they read. So sometimes you have to just, you'll use more pictures. Any last question? If not, then thanks very much for your attendance, and if you're interested, as said, you can follow the workshops in the afternoon.
Thank you very much.